we looked at 4.1 and 4.2, fundamental accounting principle and then factorial notations. So now what we need to do is we need to look at what we call permutations, and then eventually we get into combinations. So there's two words that seem very, very similar when you look at questions that are actually quite different in how you answer them. So I'm going to give you an idea as to first of all, I'll show you how they distinguish it in the book, and then I'll show you a very specific answer or example as to how that makes a difference for you. Okay, so a permutation, this is the important part, so make sure that you make a note of this, is the number of permutations of R objects chosen of set n different objects. Just a second here. A permutation is when order matters. So the order in which you select them matters. That's a permutation. Make a note of that right now. Because a combination is when order doesn't matter. And it's a very different set of outcomes. So they use what we call the permutation equation. So it's NPR. So when I want to select and arrange in order our amount of objects from n, I use NPR, in which I go n factorial over n minus r factorial. Okay?
That's for the permutation.
This is for a permutation. A consequence of this formula is that 0. Okay, so here's one thing that just a side note. 0 factorial is equal to 1. 0 factorial is equal to 1. So that's an important side note for you. So I'm going to show you two or three examples, and then I'm going to show you the difference between a permutation and combination so it makes sense to you. Actually, let's do that right now. Okay? A combination is when you are selecting NCR. So they say, in order for you to help you remember it, they say N choose R. And order does not matter in this case. So all you're doing is selecting. So let me show you how this works in a way that it's going to make sense to you. Okay? So n factorial over n minus r factorial. So it's the same as a permutation, but now I divide by r factorial. Because r factorial represents the number of ways in which you can arrange the objects that you selected. So I divide by it. So my favorite example to show is using the Lotto 649. The Lotto 649 has you selecting 6 from 49 numbers. Okay? So let's find out the amount of different ways in which you can select 6 from the 49 numbers without arranging in order. So to do that, n is 49 numbers. That's the number of objects I'm selecting from. The amount I need is 6. So 49 minus 6, 43 factorial, over 6 factorial as well. Okay, so on your calculator now, punch in 49 on your screen. Punch in 49 on your calculator. 49. Where's yours?
I can't find it. I don't know if it's in Mom's vehicle now.
You need to find it.
I know.
You got it today, and then get your calculator. Okay? Go to math again, across the probability, and find NCR. And then once you hit it, you put 6. Can I find it? Math. Across the probability. So everybody got it? So it should be 49 NCR 6 equals. How many different ways can you select it?
13,983,000.
Okay, so let's do that again. 13 million.
983,816.
16.
Yeah.
Thanks. Want to know the chances of you winning the Lotto 649 is?
1 in 13, 1 in almost 14 million.
1 in almost 14 million is the probability that you're going to win the Lotto 649. Okay.
Pretty good odds.
Yeah.
You get odds? Says
For
no.
what the Powerball is.
Okay, well now, let's get to that right away here. Okay, I'm gonna get to the Powerball in a second. Alright, what happens though if they said, alright, you have to not only get the 6 numbers right, but you have to get them in the exact order they come out.
Yeah, that's like.
Now that's a permutation. So let's do that now. So that's 49 factorial over 43 factorial. Okay, without using a calculator right now. I want you to simplify this before we do it. What does that simplify to?
49 times 48 times 47 times 46 times 45 times 44.
Yes, that's right. Remember yesterday, you expand them out, and then you cancel out the larger one with the smaller one once you get there. So you could go 49 times 48 times 47 times 46 times 45 times 44, or you can use the NPR button on your calculator. So let's do that now. 49, math, probability, find the NPR button, 6, right? And it equals
1.0068.
Times 10
10 to the 10. What is that number?
10 billion.
10 billion. If you had to pick the numbers out and get them in the exact order, you'd have a 1 in a 10 billion chance of winning the Lotto 649. Okay? Any questions so far about that? So, here's the thing. When Powerball first came out, Powerball in this happened. Powerball first came out, the chances were very similar to this. So some rich dope went and bought every possible combination he could. Spent $14 million, bought every possible combination. Because the Powerball is worth what? 200 and sometimes, I think the last one was 875 million. I think the last lady won 875 million on the last Powerball. So it's a pretty good investment if you have $14 million to buy $1 lotto tickets, right? So, do you understand the difference between a permutation and a combination now? So a combination, all you're doing is selecting the objects that you want. A permutation is you have to select them and then you have to place them in the order that they're in. Is everybody okay so far? It'll make more sense once we get into combinations, but that's a couple days away. All right, so first question. How many different permutations are there of 5 objects from a set of 7 different objects if repetition is not allowed? Okay, so that's important as well. So now we start doing more specific. So that is 7p5, which is 7 factorial over 2 factorial. So you can use your calculator, you can use the NPR button, or you can use 7 factorial over 2, essentially. Is what it is.
2,520.
2,520, right? Okay, good. far, not too bad. Marta is writing a science fiction story in which the serial number of a starship can have 1, 2, or 3 different letters, followed always by 4 different numerals. How many different starship serial numbers are possible? All right. Okay, so now, here's an issue that we have. Because she can have 1, 2, or 3, correct? And then a choice of 4 numerals. So if we were to do what we did before, here's what I would suggest. Do cases. Do cases to find out how this works. So case 1, she has a selection of 1 letter and 4 numerals. And it says always by 4 different numerals. So if she has a choice of 1 letter, how many choices does she have?
It wasn't.
26.
No.
Right? How many digits here? How many? You gotta include the 0. So there's 10. And then here?
9.
Right? Because they have to be different. It's part of the question. 4 different. So could I have done this a different way? The answer is yes. I could have gone 26, right? And then, how many am I choosing? 4 different numerals. Because they're all different, I can do it this way. I could go 10p4. So that's if I have 1. Case 2, so that I get my answer here. Case 2 then is if I have 2 digits, or 2 letters, sorry. So if I was to use my blanks, what would it be? Okay. Go, go, go.